Okay, great. Thank you very much. Multiple microphones. I'm honored to be here and to have the opportunity to speak to you. I'm honored to participate in the recognition of Hermann, Otto Hirschfeld, and I had a chance to read up on him before coming here and was quite impressed both by the breadth of his intellect and also the impact he made on his colleagues, his generosity in advising students and helping others to advance their work and advance the science. I don't think I've made anywhere near the type of contribution that he has, nor do I expect to, but I do hope to help others to advance their work. And so my objective in these lectures is really to treat them as a series of like graduate lectures in which I'll be giving examples. I'll be working through the derivations and the materials on the overhead. So I know this is a step backwards technologically, but I find it's more useful to actually write things down as I go so they don't go as fast. And I really encourage you to ask questions as we go. You'll learn more and I'll have more fun. Maybe you'll have more fun too if we interact during the course of the lecture. And I've asked Alexandra to just jump in with questions at various points, even if she doesn't have any, just for the purpose of giving a good example. Okay, so let me tell you what I have hoped to accomplish over these next 2 days. So I'm going to start in the first lecture to talk about the basic theory of skill premia. In other words, why are workers at different skill levels paid different wages, and why does that change over time? And I'm going to work with a very basic model that turns out to be incredibly powerful in predicting the evolution of wages across a number of advanced countries. And I'm going to show you where it comes from, what predictions it makes, how well it fits the data, and how it might be used internationally to understand why wage inequality differs across countries, for example. At the end of that lecture, I'm going to show you where the model starts to break down and where I think it's become increasingly inadequate. So I'm going to leave you at the end of the first lecture with a puzzle about where this model doesn't work. In the second lecture, which is later this afternoon if you're still awake, I'm going to talk about the integrating international trade into our understanding of skill differentials. And I'm going to again walk you through the conventional Heckscher-Ohlin model. And I'm going to show you how you can think about that using the same tools as we used for the basic theory of skill premia. So I'm just trying to think of these as one model. And then I'm going to walk you through a really terrific example of this in a paper by Changtai Xie and Wu, and show you how it works, and then also show you how that model actually makes the wrong predictions. So although the answers that come out are quite sensible, the model doesn't actually seem to predict the things that intuition would suggest. It actually kind of gets it wrong. So I'm going to again suggest that the model is great, and yet it sort of doesn't quite fit the facts as we conventionally understand them at present. And so I hope to leave you those two big puzzles today. So you'll be intrigued enough to come back tomorrow. And tomorrow I'm going to start with I'm going to start in the morning talking about a kind of another framework or a related framework for thinking about skill demands that tries to relate, basically puts another layer of conceptual apparatus between skills and wages, and that layer will be tasks. In other words, the allocation of skills to a set of activities. And I'll try to make the point that skills and tasks are not the same thing, although we're used to thinking of them that way, and the sort of conventional model leads you to think of them that way. So I will then talk about the possible usefulness of task models. I'll give you some recent examples from my own work and from other recent papers, many of which I've received in the last couple weeks. I am busily copying away into my slides last night for discussion tomorrow. And then in the second lecture tomorrow, I'll talk about tasks and trade, so how we can actually use a sort of a similar framework to understand trade models, and I'll come back to sort of the puzzle of the Heckscher-Ohlin model, why it doesn't seem to work so well, how we can reinterpret it through this alternative lens and get something that's I think quite sensible. And again, it's not, my goal is not to sort of undermine these models, but to sort of enrich them. And then in the final, and in time permitting, I'll also talk about an application of the similar ideas to the organization of works. So not just at the macroeconomic level, but also at the firm level, how you might change the structure of tasks according to changing technological opportunities. And then in the final lecture, I'm going to just work through some examples of testing these ideas. One will be about immigration and immigration, capital skill complementarity, and the changes in work activities, and that kind of provides a kind of a sort of a microeconomic lens on what's generally a macroeconomic problem. And then I'll also talk about changes in tasks and changes in and how it relates to what people at different ages do in the labor market as task demands change. So depending on how quickly or slowly we go, I may cover more or less than that. But I generally think that the less I cover, that means the more that you probably got from it. So the more questions you ask, the less I'll cover, the more you'll learn. So let me get started. And I want to just start off with some motivating facts. I'm going to start initially from US data, which is the data in which these theories have been most applied. But as we go forward into the more recent work on task, you'll see a lot more international evidence. So let me just start with the evolution of the college-high school wage premium in the United States. So the college-high school wage premium is typically our kind of favorite measure of the what we call between-group inequality, meaning wages at people at different skill levels. And it's a useful tracking measure because these educational credentials are reasonably well and consistently recorded over long periods of time. And so we can use it to try to, as a way of a single index of inequality, and then see how well we can understand it. So if you look in the United States, and I can use the laser pointer. This is these data are from the March, or at least the blue line from the March Current Population Survey, which goes back to 1963. And there's a very interesting evolution here. So starting from 1963 to 1975, the college-high school wage differential rises about 8 log points. So you can think of those as roughly percentage points gains, although the further go out in logarithms, the larger it gets relative to percentage points. And then plateaus in 1973 and then falls extremely rapidly, or relatively rapidly, from 1973 to about 1980. And it's interesting to note, at that time, when this was occurring, data took a lot longer to reach the analytic stage than it does now, right? So there could be a several-year lag before anyone would actually get to see the data that was processed and collected by the Current Population Survey, as Hermann, Otto, Hirschfeld no doubt have lamented. And so only in the early and mid-1980s did people really notice that the college-high school wage premium had started to collapse, that had fallen by about 13 percentage points over that period of time. In fact, Richard Freeman, who I'm sure you've all heard of, wrote a book in the early 1980s called The Overeducated American, in which he said, look, the college-high school wage premium has fallen so much that it's actually a net social loss for additional people to go on to college, because if you add up the cost of educating them and the amount, both in terms of direct costs, the opportunity costs of their not working, and then look at the wage gains that occur, it's actually, it would just be, society would benefit if fewer of them went on to college and more of them just went to high school. So in response to Richard, people stopped going to college, and actually college enrollments fell considerably. And then all of a sudden around 1980, this college-high school wage premium exploded, right? Increased incredibly rapidly. So from 1981 to about 1992, it increased by more than 20 log points, right? So that would probably be closer to about 25 percentage points at that point. And then has continued to rise steadily, although not as rapidly, through the present. And in fact, a lot of that rise is not simply college graduates, but people with post-college education. So people with master's degrees, degrees, MDs, PhDs. And so, in fact, we are now, and maybe I can see this in the next slide, at a period of historic highs for about as far back as you can remember them. So this is a figure from the Golden and Katz book, The Race Between Education and Technology. And this book was, this data is from their working paper, but it appears in their published volume. And let me tell you what this is. So in the United States, the oldest representative sample we have on education earnings is from the 1940 census, which refers to earnings around 1939. And so right before the start of the Second World War, and this would be the college, high school, the college graduate wage premium, which is college relative to high school graduates. It was at a very high level. It collapsed during the Second World War for a variety of reasons, not all of which are well understood. Some of them have to do with wage and price controls. But for those of you who follow the work of Thomas Piketty and Emmanuel Says, you know that there was a huge redistribution of wealth that occurred in many Western economies during the Second World War that basically was a destruction of wealth concentration and probably had something also to do with these kind of collapsing education differentials. And then started to rise through the 70s, and then that's that period I spoke to you about, and then this is the most recent era. Now, so you're asking, well, what is this dot here from 1915, since I told you there was no representative data from the US Census? Well, it turns out that is the data from the Iowa Census, also where Hermann, Otto, Hirschfeld taught. And what Katz and Golden did was the state of Iowa, trying to demonstrate what a progressive state it was, collected data on the education of the workforce and also the earnings, and those data were stored on handwritten cards in the public records office in Iowa, and Golden and Katz went there, and they and their research assistants, their computers, recorded that, and they used that to estimate the return to education in 1915. Now, we don't really know if Iowa is representative, but there's a plausible case that it was. And if that's so, then the college high school wage premium was quite high in that period, as makes sense because there were very few college graduates at that point, and the high-tech industry was growing very rapidly in that era, right? That was during the kind of the early decades of the kind of mass production revolution, and all of a sudden there was a kind of demand for engineering and science in chemistry, in dyeing, in production of machine products that raised demand for educated labor. So if we look at that period, presumably this decline to 1940 reflects dramatically growing supply of educated workers. And then, of course, back to here, and what you notice comparing the current era to that era is basically, as far as we can tell, the college premium, the college differential is as high now as it's been in 100 years. And so we are at a point, a historic point, that even though so much of our population has gone on for higher education, not just in the United States, but throughout the industrialized world, it's still the case that the difference in earnings that you can expect to attain for getting a college education is as high as it's ever been. So that suggests that there must have been some dramatic change in the demand for educated labor, that despite these ongoing increases in supply, we continue to see a rising wage premium. Yes?
Do you have any numbers on quantities?
Sure, I do actually. So let me see if I can come in. Okay, so here's data from the US again, and this only goes through 2000, unfortunately. But basically, this gives you the share of the population that are college equivalents, meaning college equivalents just means all those with college or greater plus half of those with some college. We just divide them evenly, right? And you can see that in 1940, under 10% of the population was a college equivalent. By 2000, it was 44%. That has risen since that time, although not as much as you would expect, because there's been a real plateauing in the US. If you look at the share that were high school dropouts, right, it was 68% in 1940 versus under 10% in 2000. Or if you're looking at high school graduates, right, at this time in 1940, there were essentially 2.5 or twice as many high school graduates as college equivalents. By 2000, there are 1.5 times as many college equivalents as there are high school graduates, and yet, right, despite that dramatic change, we see this rise in inequality. Okay. So that is and I want to say, if you look across industrialized economies, this fall in the college-high school differential was visible for almost all countries in the 1970s. This was not unique to the United States, and there are some common factors that help to explain that, which I'll come back to. Starting in the 1980s, almost all countries either saw a plateau, a slight rise, or an enormous rise in the college-high school premium, the US and the UK being the one that had the enormous rise. Now, many people think of those as one country. We think of the UK as sort of the colonies. So it's not clear that those should be thought of as separate data points. But what you see is the degree of growth in this one measure of inequality varies greatly across countries, but the entire distribution is right-shifted relative to the earlier decade. Korea being the one exception, but of course Korea had a massive influx of college graduates in that period. They had made a huge investment in education. So I want to give you the sense that this is going on in many countries simultaneously. Okay, so now I'm gonna actually shut off the screens for now, and I'm gonna write. So I'm gonna use my notes, and I want to talk about the theory of skill premia. So in other words, why do we have wage differentials, and why do they change over time? It's useful. Okay. I think that's okay. All right. Okay. So, yeah.
Just take a risk.
Okay. Okay, great. So I want to start off with a theory of wage determination, and this is going to be basing this on production functions, right? So a normal way to start off is we'd have some yt, which is output in period t is equal. Oh, well, I thought we could go for sort of the planetarium look. Okay. Oh, I see this. So this is going to have to be. Okay. There we go. No, actually, I'd like to be able to get it here and then show it there. Yeah? Okay, great. So we can think of this as a function of some k, some h, and L. Okay, let me explain what those are. So obviously K is going to be capital, H is high skill labor, L is low skill labor. AH and AL are what you call efficiency parameters. These are things that augment the supply of labor through technology. Okay, and I should say that there's a very broad range of models that could be written just in that general form, and I'm going to specialize greatly. One way I've already specialized, of course, is I've just said there's two types of labor. Right? And obviously one could be much more general than that, but I'm going to start with two, and the reason for starting with two is because it works pretty well in terms of describing what goes on. Not because there's any other, and because it's simple, but there's really no other greater justification for that. So I think, but in general, when you're writing economic models, this is something that Doron Acemoglu told me when I was starting out, which is, you don't want to make them any more complicated than they need to be. The playwright Chekhov said that if you introduce a gun in the first act, it better go off by the end of the third act, right? And so same with economic models, right? If you're going to introduce a parameter or introduce some piece of notation or some set of assumptions, you better make use of them later on. If you don't, you have more model than you need, right? So so our objective always in economics, and I think this is sort of part of the kind of aesthetic of our profession, is we like less, right? The simpler the better, right? If we can get by with supply and demand and neoclassical consumer theory, then we should do that. We expand when we need new ideas, but we always do so reluctantly, and we resent them. Okay, so. So I'm gonna start with this, and then I'm going to specialize further in two ways. One is I'm going to drop capital. Okay? And the reason I'm not going to use capital for now is because it's not actually needed for what I'm going to be doing here. But it would be easy to add it back in. And actually, whether you need it or not is going to depend on one thing. I'll ask you that in one sec. Okay, so I'm going to write down a very simple production function where I'm going to say y of t is going to be equal to at lt to the rho plus LH, actually, LH, AH, HT to the rho over 1 over rho. Okay, so this is your basic constant elasticity of substitution production function. Wow, it looks worse when I write on the overhead than on the board. I'll try to make that neater to the degree possible. Okay, so let me just tell you what those things are. LT is labor supplied at time t of low-skilled labor. This is high-skilled labor supplied at time t. This is the efficiency of low-skilled labor at time t. The efficiency of high-skilled labor at time t. This is output at time t. And then this rho thing is a parameter that is related to the elasticity of substitution between high and low-skilled labor. Right? So in particular, sigma is equal to 1 over 1 minus rho. Right, where sigma is the elasticity of substitution in production between high and low skilled labor. Okay, and yeah.
The AH is constant. You don't have a subscript on that.
I do. It's gonna. I'm gonna. Oh, sorry. So. Oh, sorry. Yes. Right. So I'll put ALT AHT. Yeah. Good. That's right. That's right. So those are. So those are what you would call. Those are factor augmenting terms. Right? And they can change over time, reflecting technological changes that raise the efficiency, the absolute efficiency of high or low skill labor. Okay. First of all, let me give you, there's multiple ways to interpret this production function before I even sort of talk about what properties it has. So one is that basically there's a single good, right, that uses H and L as inputs, right? Now, let me be clear here that we of course do not think that there's only one production function representing the economy, right? This is not, or that every firm has the same one, right? That's not correct. It's only a question of whether in aggregate we can represent it that way. So clearly, at any given firm, right, there's going to be much less substitutability between factors than there would be in the aggregate economy, right? So if you think about a single auto production plant, right, it may have what you would call a Leontief production function, right? You need this many people at this many machines, you need this much steel, this much electricity to produce this unit of output, right? On the other hand, for a given auto manufacturer, they might have multiple plants that use different technologies. So we could think of them in response to a change in the price of some input as substituting among different technologies, right, to produce the same good, and those and that would give rise to an elasticity of substitution that would not exist at the level of either plant, for example, but would exist at the level of substituting among plants, right? So when we say the economy can be thought of as a single good economy with two inputs, we don't mean to represent that represents the experience of any particular sector of the economy. Is an aggregate property. Right? And again, whether that's useful or not depends on how well it's able to describe the data, right? Not whether it's exactly represents what goes on at the neighborhood auto manufacturer. Okay, two. Another way you can think of this is you could have a two-good economy, right? Where you could have, for example, YH is equal to AH times H. YL is equal to AL times L, and then you'd have some consumer preferences, which is U of H and L, U of YH and YL is going to be equal to YH to the rho plus YL to the rho over 1 over rho. Okay, so in this case, you have two goods that are each being produced with linear technology, and then you have some consumer, this representative consumer who has preferences over these two goods, right? And here the elasticity of substitution between those two goods is 1 over 1 minus rho. Okay, and then an alternative way is you could just think of this as being a mixture, right? It doesn't actually matter for our purposes. They're all going to be equivalent, and for different applications. applications will actually want to interpret it differently, right? So for what I'm going to do today, I'll think of this as an aggregate production function. When I talk about trade tomorrow, I'll think about these as two different sectors, okay? So I'm going to talk about trade later today. All right, so, okay, so now I want to talk about what is the role played by sigma in this production function. Okay, so new slide. Okay, so first of all, this rho is going to be defined on the open interval between negative infinity and 1. Oh yeah, there we go. Okay, and so that's going to give rise to 3 possible cases of this production function. Okay, one is so remember, by the way, that sigma is equal to 1 over 1 minus rho, right? So if we have rho going toward, so if we have rho going to minus infinity, right, that's going to imply that sigma is converging towards 0. Okay, and so just to remind you, that's going to be your Leontief production function, right? So in other words, if we were to write the isoquants, right? So this is L, this is H, right? And this is output. These would be the isoquants of that production function. Right, so actually the output is the minimum of the required factors of the required 2 factors. Okay, an alternative case is where rho, so that's case 1. Case 2, where rho is going to 0, and in this case, sigma is going to infinity, right? And so that's going to give rise to a production function with perfect substitutability between factors, right? So if we were to draw that production, if we were to draw those production isoquants, right, this is L and this is H, and they would look like this, right? Where the slope is given by the relationship between AH and AL, but then the actual substitutability is linear, right? And then the third case, the third sort of special case, is where this is where rho is 0, and this would imply that sigma is close to 1, right? And so this would be a Cobb-Douglas production function, right? So this would be your Cobb-Douglas case, and the isoquants would look as follows. Right, where the marginal rate of technical substitution would be equal to 1, right, for that production function. Okay, and then we can cover lots of cases in between them, right? So that's the utility of this production function, right, is that it can span a variety of space, right? And this sigma parameter is going to be the crucial determinant of how this production function is going to respond to both to changes in supplies, relative supplies of labor, and also to changes in the efficiency parameters, so technical change. By the way, where is demand seen in this production function? So I've given you supply, or I'm telling you there's some supply of H and L, I've told you some wages. Where do we actually see demand? Where does it come from? Volunteers? So it would be helpful to me if you, my goal is not to embarrass anyone, but it would be helpful to me if, for people to sort of jump in with answers, because then I can know whether I'm making sense or not. Right, exactly. So profit maximization is a one good economy, right? So demand comes from essentially you want to get the efficient mix of factors, right? Given that you're only producing this one good, and that's going to be a function of the technological parameters and the relative supply, right? So if we're given relative supply and given so if the relative supply is fixed at a given point, we can't change supply by changing wages, but we'll want to play factors or marginal products, which will be a function of the technological parameters of production function, both the elasticity of substitution and these efficiency terms. Okay, that's right. Thank you. Okay, so so first I want to just go through wage setting. I'm going to try this other board and see if this works any better, actually. Let's see if this looks better. Okay, so Sure. Okay, good. So first of all, so you can write, not so good. Ah, I see. Oh, I see. Okay. Oh, perfect. Okay, interior optimum. Good. And then this is the focus. Okay, I'm not sure that's going to work any better, but let's try it. Okay, so wage setting in this economy is incredibly straightforward. So it's going to be wage of high-skilled labor is dy dhl, right, which is going to be equal to some function al to the rho, al to the rho plus ah to the rho over h over l to the rho over 1 minus rho over rho. Is that visible? That's worse. Okay, let's move back. Better? Much better. Okay, we'll stick with that. Great. Good. Similarly, that's, okay, is that, excuse me, this should be a minus rho, right? And similarly, you could get W8, oh, sorry, excuse me, this WH. You get WL is going to be something similar, dy dl. Or dl is going to be equal to, and that should be an h, so this would be al to the rho, hl to the rho, plus al to the, al to the rho, h over l to the rho over 1 minus rho to the rho. Okay, I can see that's going to be a little hard to read. So let me point out two things about this that are, there's two things about this that are relevant. The first is that each of these factor demands is downward sloping, right? So in particular, you're going to have dWH, dH is going to be less than 0, right? And similarly, dWL, dl less than 0. Okay. The second thing that's probably, and that's you would hopefully that's intuitive, right? That all of these would be downward sloping. But now let me ask you the second question, which is dWL dH over L. Okay. What's the sign of that going to be? Yes, did you have your hand up and back? No. Okay. So what's the sign of that going to be? So in other words, how does the wage of low-skilled workers respond to an increase in the relative supply of high-skilled labor? Yes. That's exactly. That's absolutely correct. And why? Sorry. Greater than 0. Why?
Because we have a decreasing marginal productivity of low-skilled labor and the relative supply of high-skilled labor. Increases means at the same time that the relative supply of low-skilled labor decreases, so the wage has increased.
That's right. So one way to say that is if you think about the kind of diminishing marginal rate of substitution, right? You're going to raise, and that's going to have the effect of, in general, I think the way you were phrasing it would be in terms of WL over WH, right? So in some sense, I think the question you actually, the question you best answered is dWL over WH DH DL. Right? And that's about the relative supply. This question is slightly different, and this is about the absolute wage level, right, of low-skilled labor in response to an increase in high-skilled labor supply. So that is going to be positive, right? And why? Does anyone know why that would be positive? It's less obvious. Well, if you think of H and L as being like capital and labor in your standard production function, right? In your standard, for example, Cobb-Douglas reproduction function, capital and labor are what we call Q complements, right? So the more K you have, the more productive L is. The more L you have, the more productive K is, all else equal, right? And that Q complementarity is going to be a basic property of any two-factor production function, right? That unless you're in the case where these things are perfectly substitutable, right? An increase in the relative quantity of one raises the marginal product of the other, not only in relative terms, but in absolute terms, right? So Q complementarity gives rise to this, and similarly, right, dWH, dL over H, also greater than 0. Okay, and that's a really important property because it generally means that things that augment skilled labor are also going to benefit unskilled workers, right, and vice versa. Okay, so now I want to talk about the skill premium, right, in this economy. Oh, you can't see that. Okay, so the skill premium I'm going to define as omega. Well, you won't really be able to tell the difference. Why don't I call this WR? Okay, WR equals WH over WL. That's the wage ratio, right, at a point in time. Is going to be equal to AH over AL to the row times H over L to the minus 1 minus rho, which can be rewritten as, well, yeah, all right. Actually, let me not rewrite it that way. Okay, so it's going to be a function of these two things, the efficiency parameters and the skill supplies. And it's actually convenient to rewrite this in logarithmic form, taking account of the fact that sigma is equal to 1 over 1 minus rho. So you can write this as log WR is equal to sigma minus 1 over sigma log AH over AL minus 1 over sigma log of H over L. Okay? Now, a couple things. I'm dropping, as you can see, all the time subscripts from this model. Do you think that we can put on any lights in here? Are there any lights in here? It seems awfully dark. Okay. So I'm dropping all the time subscripts here, right? But this gives you a very simple relationship between wages, the state of technology, and the state of labor supply, right? So in your own mind, you can subscript these things, H and L as having a time element, right? Those are a measure of relative supply. You can think of AH and AL as, as measuring technology at a point in time, right? And then WR being the inequality measure, for example, the college high school premium that we were talking about initially. And then this sigma, which I'm going to think of as being constant. Okay, and I'm going to take sigma as being constant for at least a while, at least for the lectures today. And it's an open question about whether you should really think of that as being constant, but we're going to work with it on that basis. Okay, so the first question is, we just want to confirm that relative wages, oh yeah, much better, good. Okay, the relative wages, how do relative wages respond to relative supply? Well, that's very straightforward. So d log WR, d log H over L is equal to minus 1 over sigma, right? So this just says, this just gives you the relative wages of high to low skilled labor as a function of relative supply has this elasticity it gives you this inverse elasticity, okay? And let me show you in particular how we're thinking about this, right? So this is log H over L. This is log WH over WL, which I've called log WR, right? And this gives rise to a demand curve, right, which has slope minus 1 over sigma, right? So holding demand constant, right, if we just move supply in this direction, right, so this is time 0, time 1, right, this wage premium falls from here to here, Okay, so the reason I draw that picture is just to remind you that although I'm doing this in relative space, like relative high to low skill wages, right, you can think of this relative supply, relative wages as being just like supply and demand in absolute terms for a single factor, right? Okay, so that's the key. So that's the sort of standard. That's the sort of standard setup of this model. But of course, this model isn't very useful for thinking about the evolution of inequality without some model of how either the demand curve is changing or how the supply curve is changing, or both. Right? So in particular, I want to ask what does the role of technological change, how does it show up in this model? Okay. Well, so the way technology changes, or the way that relative demand changes in this model, is purely through the AH and AL, right? That's the at least constraining sigma to be constant. There's only one way for that to happen, and that's through changes in these efficiency parameters, right? So in particular, we can ask what happens to wage inequality for a change in relative efficiency. Okay? So in particular, right, I'm asking what is the effect on wage inequality of a rise in the relative efficiency of high versus low skill labor, right? Now remember, these efficiency terms are simply multipliers on the H and the L, right? So if the AH term doubles, right, that's like as if you get twice as much high skilled labor for the same number of bodies. Right, you've just it's an increase in the technical efficiency of the laborers. Okay, and similarly for AL. Okay, so if you differentiate that, you find that the answer is sigma minus 1 over sigma. Okay, so obviously the sign, right? The sign of this derivative, right, equals the sign of sigma minus 1, right? So in other words, if sigma is equal to 1, a change in relative supply has no effect on wage inequality, right? If excuse me, not relative supply, excuse me, a change in these efficiency parameters. If sigma is greater than 1, right, a change in relative efficiency of high versus low skilled labor raises the high skill wage, right? And if sigma is less than 1, a change in the relative efficiency of high skilled labor lowers the high skill wage. Okay? What's the intuition on the latter, right? Why is it the case that if sigma is less than 1, an increase in efficiency of high skilled labor causes the high skill wage to fall? I can stand here for a long time. Someone want to venture? This is really, I'm really not trying to embarrass anyone, but it's very helpful to me if someone ventures a guess, then I'll have some sense of whether I'm. Yes, thank you very much. That's right. I think you hit on exactly the right term. So actually, so when sigma is less than 1, right, that means that they're gross complements, right, because they're not very substitutable. And so when you raise supply of high skilled labor and it's strongly complementary, it raises demand for low skill labor as well, right? And you actually get something like excess supply of high skilled labor, right? So for example, take the extreme case of Leontief production function. You need one high school worker and one college worker to produce 1 unit of output. Well, if you increase the ratio of college to high school workers from 1 to 1 to, let's say, 2 to 1, right? Then all of a sudden you have excess supply of high skilled labor, right? And so in that case, that would have the effect of reducing the wage of high-skilled labor. So we can think of a rise in AH over AL as being equivalent to an increase in the effective supply of high-skilled labor, right? So if this elasticity of substitution is less than 1, then that's going to have the effect of diminishing high-skilled wages. So it's an important distinction to make, right? Because when people say, you know, oh, this is a skill-biased technical change, for example, right? You actually have to. It's not clear what that means without defining terms, right? Because you could say a skill-biased technical change, in one sense, is something that raises AH over AL, right? Increases the efficiency of high relative low-skill workers. That seems like a very straightforward definition. And you say, well, what are the implications of that for inequality? Well, it actually depends on the nature of production, right? You can increase someone's productivity and cause their wage to fall because you need less of them, right? In fact, that's been historically, this has been the concern about technological change all along, right? That basically, when technological change, when technology improves, we need less labor to do the same amount of stuff, right? Does that raise or lower wages of workers? Well, it actually depends, right? So in aggregate, an increase in productivity is going to increase output. And it's going to raise societal welfare, but that may be good news or bad news, right, for people who do that job, right? So if you're a machinist on a production line, right? Does increasing the efficiency of machining raise or lower your wage? Well, it depends in part on how elastic demand will be, right? So whether you can actually make use of all that additional labor, or whether you're going to just hire fewer workers to do the same job. Okay, so this is an incredibly important point for when we think about this model. We actually have to have an idea in mind of what this sigma is, right? So in particular, it's going to matter if sigma is greater than 1, then H and L are gross substitutes. In that case, it's going to be the case that wage inequality will rise when we have a skill-biased technical change. And similarly, if sigma is less than 1, then H and L are gross complements, right? And wage inequality will fall when we have a so-called skill-biased technical change. Okay, so now I want to, so that's sort of a tiny little conceptual apparatus. And now I want to say, well, how would you use this kind of static model to understand the evolution of wage inequality? So the answer is, well, there's not a single answer, but one way you might think about it is what some call the education race view. And this goes back to the Nobel Prize-winning economist Jan Tinbergen, who said, well, we can think of the evolution of inequality as reflecting a race between technology and schooling. So technology is forever raising demand for skill, and schooling is forever raising supply of skill. And so what happens to inequality depends on how fast those factors operate. So if technology advances faster than supply, then wage inequality rises. If supply advances faster than technology, then wage inequality falls, right? So how you might see that visually, right, is you could say, okay, well, here at a point in time is your demand curve. Here at a point in time is your supply curve, right? And then as time advances, right, this is moving out at a steady state, let's say. Doesn't have to be true. Okay. So all else equal, if the demand curve moves outward, right, without a shift in the supply curve, wage inequality rises, right? So we would go from being, this would be WR0, this would be WR1. Right? On the other hand, if supply curve moves outward by the same amount, right, then we're just we're at a new equilibrium with the same initial wages. Excuse me, I guess I should have drawn that like that. Okay, so if the supply curve moves out by a parallel amount, right, this is S0, S1, right, it's possible for wage inequality to remain unchanged, right? And so this simple little model, you have these Marshallian scissors, and the question is, which blade moves out faster, right? Whether it's the demand blade or the supply blade, and the difference in those movements would then be predicted to determine whether high and low skill labor, whether the high and low skill wage or the wage inequality rises or falls. Now I know that that sounds trivial, right? It sounds rather too simple to be empirically useful. But it turns out that that actually does surprisingly well as a very simple description of a lot of facts. So let me start. So the paper I want to talk about briefly that brings this model to the data is, just looking for the right color pen for this, is Katz and Murphy in 1992. Okay? And so go back to this equation I wrote a minute ago. Log WR is equal to sigma minus 1 over sigma log AH over AL minus 1 over sigma log of H of L. Okay, so this says the wage inequality at a point in time is a function of sigma minus 1 over sigma over log AH over AL. You can think of that as the position of the demand curve, of the relative demand curve, plus minus 1 over sigma log H over L, which is the position of the relative supply curve. Okay, well, you could say, think about how could you use this for actually estimation, for learning something. Well, clearly, this is observable. Right? So we can observe at a point in time the inequality between workers of different skill levels, maybe with greater degrees of bias or precision. This is observable, right? We can observe supplies. And when we say supplies, there are various ways to think about supply, but in general, it's useful to think of most industrial economies operating at full employment. So even if only 95% of people who could work are working, right? We think of that as being the available supply of labor at a point in time. So we can think of it, so we can in theory measure this thing. What we don't get to observe, right, that's what we want to infer, right, nor do we know what this sigma is, right? But we might be able to do okay despite that, right, by estimating something like this. We could say, well, if we're going to take this to data, we'd say log WRT, so that's the high-low skill labor ratio, wage ratio viewed at a point in time, is equal to some constant, some intercept term, sigma 1 times t, where t is time, plus gamma 2 times log H over L t, plus some error term t. Okay, so let me talk about what this does, what that equation estimates. So, sorry. Okay, as I said, these things are observed, right? This sigma 0 thing is a negligible term. That's not actually important. Sigma 1t, well, what's that doing? Well, basically, we have this is a time series model, right? This is just on the dependent variable is the wage ratio, the independent variable is the supply term, right? And we don't have enough free parameters. We don't have enough data to get a lot of free parameters. So what we need to do essentially is we need to fix some parameters to estimate others. So if we specify, so this sigma 1, right, is going to be related to this, this gamma 1 is going to be, so gamma 1 is going to be essentially related to 1 minus sigma minus 1 over sigma times log AH over AL t, right? And we can think of this as the time trend on this demand term, right? And so in the Tinbergen sense, right, this would capture the secular movement of rising demand for skill, right? Normalize with the assumption, the normalization, and not an innocuous normalization, right, that there's basically a constant proportional rate of change in the productivity of high versus low skilled laborers, right, the efficiency term. Right. If that's correct, right, and we specify this model correctly, we fit it to data, right, what should drop out of here right? Well, it should be the case the sigma hat 2 is an estimate over, of 1 over the elasticity of substitution, right? And so if we fit this thing to aggregate data, we ought to be able to, it's going to make two predictions. Well, it's going to predict, first of all, that all else equal, when supply rises, wage inequality falls. 2, holding supply constant as time goes on, right, wage inequality should tend to rise. So if we just hold supply constant, that would reflect the sigma 1 times t term. And then thirdly, if we actually have the right model, that we can interpret sigma hat 2 very structurally as reflecting a technological parameter of the economy, right? Okay, let me show you what this model actually does. Now here I may need my 2 blackboards, or whiteboards, or whatever they are. Okay. Okay, good. So, great. All right, so let me show you in particular. This is from Katz-Murphy's 1992 paper. This shows you the detrended college-high school wage differential. So they started in 1963, here's 73, and their data only go through 87. Now, notice, by the way, this paper was published in 92. The data only go through 87, right? That reflects that historical time lag of getting access to data. So here's the college-high school wage premium rising and then falls in the 70s and then rises to 87. They had no idea, right, where this was going to end up by now. Okay. Here is the detrended log relative supply of college graduates, right? So this is basically, so what you see, detrended means they've just they've just rotated essentially by taking out a trend, and you see that it's accelerating in the 70s, right? It's increasing, and then around 1981, 82, 83, it falls off a cliff. Right? There's a dramatic deceleration in relative supply of college high school labor. Okay, so let me tell you, so now I'm going to try the other board here and see if this works. Okay. No? Oh, I see, okay. I think it only wants 1. I think it wants that one. Yeah. That's going to work. Yeah. Okay. Yep, that's okay.
Lazy.
Okay. That's all right. When it finally warms up, you'll see what I've written, and you'll be floored. Okay. And some plus some constant, and okay, good. All right, very good. Okay, so you can almost see that. Oh, that's good. Okay, so a couple things. All right, so here's what comes out of this, first of all. So this equation from their paper says that the evolution of log wages, there's some constant, that's alpha hat, this would say that this demand term is trending at 3.3 log points a year. In other words, the demand curve is shifting out 3% a year. The second thing is that, as predicted, right, this term on relative supply, log relative supply, is negative, right? So in other words, all else equal, an increase in relative supply reduces the wage premium. And moreover, that 0.71 actually has a specific interpretation, which is that 1 over 0.71 is approximately equal to 1.41, which is almost equal to the square root of 2, universal constant. So what this actually implies is that sigma hat is approximately equal to minus 1.14. Right? So the elasticity of substitution between high and low skilled labor is around 1.4. Now, let me show you how well that actually works, right? Believe it or not. So here, let's see, it's very hard to see in this figure. No, here we go. So the line on top is the actual evolution of the college high school wage premium, so it goes up and then down, right? Here, this other line with the solid circles, right, does the following. It goes up, it goes down, it misses a bit, and then it catches right up with that wage series again. right? So strangely enough, this actually provides a fairly good description of the evolution of the college high school wage premium in the United States for those 25 years. Okay? And what's doing all the work in this estimation? Well, one thing that's doing some work is this time trend, right? If you didn't put that in, you get the wrong sign. Right, this would say when college, high school relative supply increases, wage inequality increases, right? Because both of these things are trending outward, right? So you need something that allows demand to shift, right? And the other thing it says is, the other thing that's doing a lot of work here is this, right? This huge deceleration in relative supply of educated labor, right? So this basically says demand is moving out 3.3 percentage points a year, right? And all of a sudden, and supply is moving along with it, right? And then all of a sudden, in the early 1980s, we sort of hit this wall where there's this huge, this dramatic plateauing of supply of skilled workers, and that gives rise to this increase in the wage premium. Okay? Now, I'm going to show you some limitations of that, but let me sort of say, as a starting point, it's a remarkably, yes?
You didn't impose a restriction on two coefficients. In some sense that, they're kind of related. One is sigma minus 1 over sigma.
That's right.
Over sigma. And I think you do that, you probably get different coefficients.
Absolutely. So I had Katz and Murphy make up this other figure where they, what they do is, so instead of imposing, right? So you can estimate, you could estimate this non-parametrically, right? Or just if you knew what that sigma was, right? So if you knew sigma, right, you could subtract off, minus 1 over sigma times log WH over WL, look at log WT, and you could get the implied T in each period, right? So let's do that. So if you look at the solid line, this is 1.4. This is this elasticity is equal to 1.4, right? This line gives you the implied value of this demand term. So sigma minus 1 over sigma times log WH over WL, right? Excuse me, times log AH over AL. That's your elasticity term. And not surprisingly, that looks like a line, right? Because that, in some sense, that's going to be the best fit, the way they've done it. Okay, you could do it differently with the sigma is equal to 0.5. You could do it again and assume sigma is equal to 0.4, is equal to 4, right? And that gives you this very wavy series on the implied changes in demand. Okay, why? So in other words, let me make it clear. What this says is the demand changes, the acceleration or deceleration, are much, much more dramatic if we assume that high and low skilled labor are very substitutable. Does anyone? Why would that be true? Why does that why does that follow? So if I say these things are, high and low skilled labor are very closely substitutable. So elasticity of 4 is, pretty much not that far apart from almost being perfectly substitutable. Why does that imply very large changes in relative to demand to explain the wage series that we see? Right, so, yeah, exactly right. Because the fact that they're so substitutable, right, to see the amount of wage inequality movement we've seen, it would imply there had to have been dramatic shifts in demand, right, to give rise to those changes, right? So if these things are very close to substitutable, even large movements in relative supply wouldn't give much change in wage inequality because these two factors are almost the same, right? So to interpret that, we would need to have very sharp movements in relative demand. Right? So, but I guess what you get out of this is, even assuming this 1.4 thing, right, this series of implied demand shifts is very linear, right? So it actually seems to be a relatively adequate, or at least a good starting point for a description of the data. Okay? A couple points about this. So what people tend to remember, well, two things. One is people tend to think of the Katz-Murphy paper as representing the idea of skill-biased technical change. But actually the main point of their paper, right, was that the largest determinant of wage inequality, at least of observable changes in wage inequality, was changes in supply. Right? There was a secular trend in demand, right? And you could overlay on that changes in relative supply, and they could do a very good job of explaining the data, right? So notice there's no acceleration in technological change in this picture, right? You just need smooth trending demand changes and changes in supply, and that could get you a long part of the way. That's one thing that people remember about their paper. Or sorry, that's one thing people misremember about their paper. The other thing that's ironic about their paper is when it was written, it was basically the most data-intensive empirical paper in economics that had ever been written, right? So they had over 1 million observations, which at that time was remarkable, and it had to be done on mainframe computers, and in fact they could only run it twice because of the cost of computing. They used, so normally we do hundreds of thousands of specification tests, right? They could run it two ways where they crunched these cells down. One was using one version of the minimum wage, and one was using just the, so one imposed, threw out people at half in the 1982 minimum wage, and one just dropped it to the bottom 1% of the distribution or something. Turned out not to matter. This used an incredible amount of processor time. It was incredibly data intensive, and of course this estimation involves basically 27 data points, right? So the thing that people remember about their paper is the thing based on the 27 data points rather than the massive computational exercise that they did. And so it was a great historical achievement, and it didn't matter. Okay, okay, so now that's a good starting point, but then, yes, go ahead. Good. Okay. So actually, so what went wrong, or so more precisely, yeah, why didn't this thing? So this thing says inequality should start to rise in the late 1970s and the early 1980s. Very good question. But in fact, it doesn't start to rise until this later period, right? And the reason you see that, right, is if you look at this detrended demand, it's slowing in the 1970s, right, and it doesn't fall off the cliff until 1982 or 1983, right? So in some sense, this model, what this model gets wrong is that it predicts that we should have seen inequality start to increase earlier, and we didn't. And I think the answer is we don't know, right? And this is actually, and this shows up in a lot of papers, that this divergence between the model and the data, right, is unexplained, and then basically it's as if the data notices that it's deviating from the model, and 5 years later snaps back onto target, right? So I don't think we know. I think probably the best answer would be that there were very strong macroeconomic trends in the late 70s, which were relatively positive, followed by economic collapse, right, following the second oil shock, and a huge rise in unemployment. So basically, it's possible that those macroeconomic conditions were relatively favorable towards low-skilled workers in the late 70s, and then extremely unfavorable to them in the 1980s. Right? That would be our best. That would be our best guess. But it's a very astute question, and the correct answer is we don't know the answer. Okay. Sorry. Okay. Right. Okay. So let me show you. What's going on here? Well, as I said, the crucial thing that's identifying this model is this log relative supply term, right? And that is, it's basically this one inflection point where it decelerates in 1982. That's what's really doing all the work. And this is the detrended thing. And just to show you where is this coming from, okay, I guess I don't have the picture here, but I'll come back to this. First of all, let me show you a couple more things. So this, by the way, is from the Golden and Katz book that I mentioned earlier, their education race book. And they fit the same model to the data for 1915 through 2007, I believe. And you can see it does remarkably well, right? This is for the college high school premium. And so this model works reasonably well out of sample as well, right? Where out of sample includes going back, 70 years, right, or going forward another 20 years, right? The Katz-Murphy estimation ends in 1987. Okay, I'm going to show you where it deviates, but let me not do that now. Let me say two things about this, and I regret that I don't have the slides in front of me. There were two factors that help to explain this inflection, this deceleration in relative supply, which you see here. Okay, one of them is the passing through of the baby boom cohorts. So basically, the last baby boom cohorts were born in the United States, at least, around 1964. And so they basically had completed college in the early 1980s. The cohorts that came after them were smaller. right? So even if those cohorts went on to attain college at the same rate as earlier cohorts, the rate of increase of total educational attainment had to decelerate, right? Just because even if the marginal workers were were even more educated than those that preceded them, there were fewer of them. That was one factor. The other factor that was incredibly important was the end of the Vietnam War. We had many people in the US who stayed in college as a way of draft deferral. Right? This happened for men. It happened for women as well. They weren't at risk of being drafted, but there might have been other reasons to go to college when there were a lot of men there. And so the end result was when the Vietnam War ended, both male and female college enrollment fell quite dramatically. Right? And so those two factors were sort of built into labor supply so that by the early 1980s, smaller cohorts plus slowing rates of educational attainment led to this sharp contraction. Okay? And so that contraction can explain a lot of what happened next. Okay, yes?
These are just men, right?
Actually, no, that's men and women.
Because I think Murphy-Katz was just men.
Well, actually, so what they did, this is, their wage measures were just for men, right? They used full-time, full-year workers as for their kind of price series, but then for quantities, they used men and women, right? So their assumption was that they were perfect substitutes.
They weighted by the wage or something.
That's right. That's right. So they weighed by efficiency units. That's right. But up to efficiency units, the assumption was they were perfectly substitutable. There was no, concave substitution between them. Okay. Okay, so now that's an application to the US data. I want to do two additional things in the next half hour. One is I want to show you the sort of applicability of this model across a broader set of data points from multiple countries in a slightly enriched framework. And then I also want to show you some evidence on whether we can think of differences in wage premiums across countries as reflecting differences in skill supply and demand. Okay, so I think those are both useful. So two reasons I want to do that. On the first point, I just want to show you that this model is not just rigged to fit these data, right? Obviously, with this few data points, even with kind of 2 parameters relative to 27 data points, it's not that remarkable, right? I mean, the ratio of independent observations to parameters is relatively favorable for the model with only 27 data points. And two, so I want to show you that this actually can get you further. And then I want to show you across countries that I think you want to ask whether is it even useful to sort of start with a supply and demand framework as a way of interpreting international differences in wage setting. Because if we don't think that supply and demand is the right place to start, then this model might have high explanatory power in one case, but it wouldn't be particularly applicable, and we shouldn't be focused there. Okay, so let me do that. And so the first paper I want to talk about is I do have the slides. Okay, so the paper I want to talk about, and I'm just going to talk about it briefly. I'm not going to work through the entire paper. Is the Cardin-Lemieux paper from 2001 in the QJE. And I should say, by the way, on my website you will find all these things in my graduate lecture notes that are derived fully and worked through. So don't feel that you have to try to understand what read what I'm writing, and B, copy it down. Okay, so it's all online. So there's much more information available. Okay, so this is what I meant to put up a moment ago. So this is cohort size, right? 18 years later, and you can see that basically this peak here around 1981, that's the last baby boom cohort. Right, and so cohort size starts to decline. Of course, 18 years later is relevant because that's when people would start to hit the labor market, right? So cohorts start getting smaller around 1980, 81, 82, and then fall off further from there. Okay, and by the way, for at least in the U.S. data, right, the first large cohort is from 1942, which is just as the first big waves of men were shipping off to war, right? So Orly Oschenfelter is of that cohort, and then the baby boom really kicks off in 1944 when the war ends, right? Okay, here is the fraction of 12th grade men who enter college right? So people, when they complete high school in the given year, do they enter college? And you can see, right, that this is relatively high in 73 and then declines considerably thereafter, right? Now, there are two explanations. One is the end of the Vietnam War. The other, as I mentioned, was Richard Freeman's book. But Freeman's book came a bit later, so it probably the Vietnam War. And similarly, this is the fraction of the cohort with a college degree by age 40. Okay, and you can see that for these later born cohorts, right, for men, there's an absolute decline. For women, there's a plateau, right? And it is the case in the US data that this represents two important things that start at this point and continue. One is that, in fact, the rate of rise of college going has slowed a lot. And the other is that women have converged with men and overtaken them. Right? And that's true across all industrialized economies, as far as I know at this point, that women are relatively, or have a much greater rate of college going than males do. Right? Okay, good. But here is a really important puzzle that comes from looking at these data, right? So the model I showed you was one where we have two skill groups, high and low skill labor, right? So that implies that there's one wage premium, which is the college wage versus the high school wage. Now, of course, there may be, that's not going to be a perfect model. There's going to be variation around that. There may be differences in cohort quality. But one thing that's really odd is if you look at the college high school wage premium for older workers, 46 to 50. Now these are middle-aged, not old, just to be clear. And these are younger workers, right? If you look in 1980, the college high school wage premium for the young rises relative to the college high school wage premium for older workers. If you look in the UK, you see something similar. Although what's actually remarkable is in the US it starts about 5 years earlier. Right? So in the US we see this big leap 80 to 85. In the UK we really see it 85 to 90. Right? If you look also in Canada, right, you see a little bit of this. Now everything always happens less dramatically in Canada, right? So this is not surprising. You need to scale by the Canada factor. But nevertheless, you still see some convergence of Canada, of the wages of the young relative to the old in the Canadian economy relative to the US economy. Okay. So the question is that a useful observation? Does that tell us something about how we ought to be thinking about this whole panoply of the college high school wage premium? So one response to that is to say, well, we should throw out the model because it doesn't predict this, right? An alternative is to augment the model a little bit, and now I'm just going to tell you descriptively, right? So you can think of that workers of different ages are imperfect substitutes for one another, right? So a 50-year-old college worker and a 20-year-old college worker, they're both college workers, but they're not going to be perfect substitutes because they're going to differ in their aptitudes and their experience, right? So you can think of, you generally don't see 20-year-olds, college workers heading large corporations. You don't generally see 55-year-old college workers, managing your local McDonald's, right? There's a difference in what they do, right? And that probably is some function of experience and aptitude. Similarly for high school workers, right? Younger and older high school workers do different things. So you might augment the model that we wrote a moment ago by saying, let's imagine that people of the same education but different age levels are imperfectly substitutable. Right? So, for example, you might say, well, college and high school, graduates of different ages, they're pretty closely substitutable, maybe more so than college and high school workers, right? But not perfectly so. Similarly, for high school workers, older and younger high school workers are pretty close substitutes for one another, more than are college and high school, but not perfectly so. Well, what does that imply? What does that imply for what's going to happen to wage premiums at different age levels as supply changes? Well, think about the following, okay? Here is the relative supply of 46 to 50-year-old men for, this is the college high school relative supply in the US, in Canada, and in the UK, right? And what you'll notice is, and these are log linearized, or they're on log scales, and what you see is the intercohort trend across workers of those age ranges, right, is fairly smooth. In other words, basically, if we look at older workers, the percent increase in college supply is basically rising steadily at the rate of about 2 or 3 log points per year right, at the rate of about 20 to 30 log points per decade. If we look at young workers, right, the intercohort relative supply in the US decelerates in the late 70s, right? In the UK, it decelerates in the early 1980s, and then in Canada it does something, you know, kind of wishy-washy. Okay, so what is it? The reason that that's important and interesting, right, is because when young people reduce the rate of college going, what that means is that the relative supply of young college workers is going to decelerate much more rapidly than the relative supply of older college workers, right? And so it takes, you know, decades for that deceleration to work its way through the labor market, right? So even when the young decelerate, right, the supply of older college workers the relative supply is still increasing, right, because those people got college education decades earlier. So if workers of different age or experience levels within an education group, right, are imperfectly substitutable, that means that the relative supply of young college graduates decelerates much faster than the relative supply of older college graduates, and that would suggest that the college high school wage premium would rise by more for the young than for the old. Right? And moreover, that premium would follow these groups through the labor market as they age. Right? So, I'm not going to work through the analytics of that, but let me just sort of show you in particular. Okay, so here, remember I said a few minutes ago, right, that the college high school wage premium for the young rose 5 years earlier in the US than it did in the UK. If you go back to the supply data, right, you can see that the supply decelerated 5 years later in the UK than in the US. The baby boom went longer in the UK. And also the decline in college going was also less rapid. It's interesting, by the way, most countries did not have draft deferrals, but most countries saw a decline or a flattening out of college going after the end of the Vietnam War. So maybe it just was college was a good place to be during the Vietnam War for a variety of reasons having to do not just with avoiding the draft, but all the other fun things that were happening in college at that point. Okay. So similarly, let me just sort of show you in more detail. This is the US data now doing this on an annualized basis. So this is the relative supply of inexperienced college workers under 10 years. This is the relative supply of experienced college workers, 20 to 29. And here you can see that these are roughly parallel until this period, until like the mid-70s. And then this one flattens out, right? Similarly, this is the college high school differential for young workers. This is for old workers, and you see this jump up, right, which follows with something of a lag, right, about 4-year lag, what happens to relative supply. Okay, good, all right, and so putting these two pictures together, right, you can roughly see that when this one decelerates, this one jumps up, right? Now, I won't take the time to do this, but if you read the Cardinal-Lemieux paper from 2001, they do the same exercise for the US, the UK, and Canada, and they fit the same production functions with it. They get an aggregate elasticity substitution between college and high school labor, and then they get a age group specific elasticity of substitution between college and high school graduates of different ages. And remarkably, they actually get the same elasticity of substitution across age groups in an education group in all 3 countries, estimated separately, and the elasticity of substitution they get for college versus high school workers in aggregate is about 2, which isn't that far from 1.4. And actually, if they focus on men and women together, they get something much closer to 1.4. If they do men only, which most of their paper does, then they get 2. But that's not surprising. That would be a higher number. So that exercise, taking this very, very simple model and applying it to a broader set of countries and a broader set of facts, actually does extremely well. Right? And I can say that there are a number of papers that also fit similar models to US and international data and do pretty well with it. So I'm just going to mention a few. There's Borjas 2003 in the QJE, and this is about the substitutability between immigrants and natives using this experience group idea. Right, as I already mentioned, there's Card and Lemieux, 2001, in the QJE. There's Asamoglu, Otto, and Lyle in 2004 in the JPE, which does this looking at class distribution between men and women around the period of the Second World War. But all of these fit different variants of this CES model, and all of them produce startlingly informative, I think, or maybe this one isn't informative. The others produce startlingly informative estimates of, that help to explain the evolution of skill differentials across groups within countries over time. So what I want to suggest with this model is not that this is the God's own truth for understanding the labor market, but only that it's useful to start as simply as possible, and they can get you a very long way. Although I'm going to show you in a while, it only gets you so far. Okay, but the reason I want to just mention these other papers is to point out this tool is not at all specialized to this particular example. In fact, this is really the workhorse model in labor economics has been used not only by the people I mentioned, but by Finus Welch and by Murphy and Welch in earlier work as well. Okay. So now I'm going to talk about international differences in wage inequality. But before I do, any questions or reflections or criticisms or in general on the stuff we were just speaking of? So I knew you weren't going to say anything, so I decided to take a break. Okay. I think so. Again, I just want to emphasize that my objective is not to suggest that that is a complete explanation. It's really only to put forward the idea that you can get reasonably far with a fair amount of important in explaining some of the important trends by using this very simple starting point. But of course, even the cardinal mu exercise is really only applying this to Anglo data, right? The US, UK, and Canada. And as I said before, many people would think of those as being, at most 2 countries, maybe only 1.5, right? So you'd like to know if could you understand other cross-national differences in wage setting by trying to do something similar. So now I want to talk about a paper which is less well known by Oosterbeek, Van Leeuwen, and Oppum. And this is about understanding international differences in wage inequality. And so first of all, they put up some figures from the IALS, the International Adult Literacy Survey, that show you measures of inequality. So this is 50-10 and 90-50 log wage differentials for men at a point in time across a variety of countries. So you can see, for example, the US has extremely high levels of inequality by both of these measures. Sweden has relatively low. And in Italy, there's more wage inequality at the top and the bottom and so on. But these differences are quite dramatic. So for example, this difference here is 160 log points between the 90th and 10th differential. That's a factor of about 5. And this difference here is under 100 log points, right? So that's under a factor of 3. Right, or approximately a factor of 3. So these, although in log terms these don't look that different, these are enormous differences in wage dispersion across countries. So the question is, can they be understood as reflecting differences in the supply and demand of skills across country, or are they really primarily institutional differences? And so Blau and Kahn have a paper, and this is the same thing for women, I should just mention, in 1996, it's called International Differences in Wage Inequality, Supply, Demand, and Institutions. And their paper attempts to estimate a kind of an international wage setting schedule and ask how far supply and demand, viewed through that lens, can go in explaining international differences versus institutions. And their paper rejects supply and demand explanations entirely and says the entire difference can be understood as institutional differences. And that result was so startling that it was published in the JPE. And I should say the JPE, as all of you know, is the University of Chicago journal, and they only publish 2 types of results. Either results that completely confirm neoclassical theory, or results that so radically reject it that they can't somehow just dismiss it out of hand, and so they have to publish it as a sort of a kind of to show that they're embarrassed, but they're willing to face the truth. So this was a very startling paper, and And the paper by Oosterbeek, Leeuwen, and Van Oppen comes back to these results and says, can we do any better with using slightly different data methods? And in particular, they focus on the IALS, which is, which some of you know, that's the International Adult Literacy Survey. And it was a really heroic effort to collect internationally comparable measures of skill supply or skills across countries. And in particular, they used, most international comparisons use very non-comparable measures, right? So years of education isn't very comparable across country, and test scores are not necessarily very comparable as well. So they had these practical tests of, read a newspaper article, interpret what it means, do the following calculation, and these were all translated very carefully and then benchmarked to make sure that they felt confident they were measuring the same things across countries, and then those could be used to measure skill levels comparably across countries. So in particular, this is a very nice figure from Leeuwen, Oosterbeek, and Van Oppen. This is the years of schooling on average in a country. This is the average ILS score. And what you would see is this is roughly linear, but there's some clear outliers, right? So Sweden has much higher test scores than you would expect based on this fit of education. And the US, of course, has much lower test scores. So we're basically a high education, low attainment type of a country. And those of you who have been there would recognize that as being the truth. And so their paper says, well, could we, maybe the reason that supply and demand don't do such a very good job of explaining cross-national differences in wage inequality is that we're not measuring supply and demand very well. In particular, if we want to look at supply of skills, we wouldn't just want to use years of education, right? Because that would, for example, cause us to estimate that the US has much greater relative skill supply than it does, right? We want to use a measure of supply that's internationally comparable based on actual cognitive capabilities, right? So the question is, how can you do that? And here's the technique. And now I'm gonna write some of these down again. So let me. Okay. So there's no completely natural or easy way to make cross-national comparisons of supply and demand, even if you have measures of skill. But they make, I think, what's a reasonable first effort, which looks as follows. So let's say for each country, they're going to do as follows. So here's supply of skill K in country J is going to be equal to a relative supply log of EKJ relative to EKB, where B is the base country, J is the comparison country, and K is the skill tercile. Okay, I'll explain what that means. So what they do is they take a base country, could be any country, in fact they're going to do all of them, and they're going to take the skill distribution measured by the IALS, and they're going to divide it into 3 terciles, right? So the base country by definition has 1/3 of its skill supply in each of those bins, right? Then the relative supply of some comparison country J is the ratio of supply in that bin, right, relative to the base country. So if it has exactly the same supply, that ratio is 1, the log ratio is 0. There's no difference, right? If it has relatively greater share in the highest bin relative to the base country, then that supply is going to be positive, right? If it has relatively higher share in the lowest bin, then its relative supply of the low skill group will be high and will be positive, and the relative supply of the high skill group will be negative, right? So it's just a way of normalizing, okay? But the key thing is you're normalizing using the measured percentiles of this comparable skill distribution. So that's going to be the relative supply of country J relative to country B for each of these 3 skill groups, okay? Now, what do we do with demand? Well, demand is actually harder. They're going to write the following: DKJ, so the relative demand for skill group K in country J is going to be equal to log of 1 plus sigma 0, I'll explain what that is, COK times delta EO over EKB. Okay, what is this? So so O is basically industry occupation groups. Okay, so we might say, you know, in manufacturing you have production and non-production. In insurance you have these skill groups. In you know, retail trade you have the following skill groups. So we're going to try to break these countries up into 25 or so, or 26 or 24 actually, comparable industry occupation groups. Okay. Now COK is the share of worker in the occupation industry group who are in skill group K in the base country, right? So it's going to be some number between 0 and 1. On average, will be a third, right? So if an industry occupation cell is high in group 1, that means, or being the K group 1, skill group 1, that means that it's relatively intensive in the highest skill group of workers, right? So what is this? So this delta EO is the difference in the share of employment in country. Oh, sorry, EOJ, there we go, thank you. The difference in the share of employment in country J relative to employment in country, in the base country, right? We're normalizing by the relative supply of the skill group, and then we're multiplying by the skill intensity in the base country, right? So this basically says we take each country, we compare its employment distribution relative to the base country, and then we multiply by the skill intensity of the base country in that activity to ask what is the demand for skill in the comparison country. So if that country had the same distribution of industries and occupations, we would say, based on this, it has the same demand for skill. If it's relatively concentrated in the industries and occupations the base country has high skilled workers in, we would say it's relatively skill intensive. If it's concentrated in the industry and occupations in which the base country has relatively few skilled workers in, then we would say it's has relatively low skill demand. Right? Is that clear? So we're basically just looking at the mixture of activities and multiplying them through by the way those activities are produced in the base country to get a sense of how much skill essentially the base country would need to produce this set of activities. That's right. So there's an assumption here that everybody has the same technology. There's a further assumption, by the way, which is not right, which is that you can think of the supply and demand as being independent in a country. But clearly a country that has relatively few skilled workers is not going to be specialized in very highly skilled activities, right? So in some sense this is going to tend to underestimate the demand differences across countries, right? Because these are going to be simultaneously determined. But nevertheless, okay, but you can see is a country that has exactly the same skill mix as the base country, this log index will be equal to 0. Right? And if it has a lower skill mix, it'll be in terms of demand, it'll be negative, positive skill, maybe positive. Okay, good. So then they're going to estimate the following regression. This is the wage of skill group K in country J minus the wage group of skill group K in the base country, right, is going to be equal to some intercept plus beta times SKJ minus SKB, so relative supply, minus DKJ, minus DKB. So I'm sure that's clear. Okay, oh good, all right. So you can almost see that. So this says, so we're going to estimate the wage, for example, this is the high skilled workers, right? This is the top group. The relative wages of the top group in the reference country relative to the base country, excuse me, in the current country relative to the base country is a function of relative supply minus relative demand, right? So this basically says that beta, right, we'd expect that beta hat is negative, right? So if we have net relative supply, then the wage differentials will be smaller, right? And moreover, we can do slightly better with this analysis if we look at, for example, so I'm going to call that thing delta WJ, right? You can do, for example, delta W for group 3 minus group 1, for example. WJ1 is equal to some alpha plus beta times, I'm going to call this thing delta NS for net supply, plus gamma J. So here you can put a whole set of country dummies, right? And just be looking at, we say, well, what's the wages of very high skill relative to low skill, or wage of high relative to the middle, right, as a function of differences in relative supply within that country across groups, right? And this would be plus, sorry, that's a J, plus epsilon J K. Okay. Okay, so is it clear the exercise here? So the idea is we're going to look at we're going to look across countries at relative wages of different skill groups and ask whether we can understand those relative wages as differences in the relative endowments of those skill groups across countries and the mix of activities that we project as being more or less skill demanding. And because we're going to compare within country differences in these differentials, right, we can essentially put in a main effect for each country, so we're only learning about the degree of wage difference between high and low skill workers, for example, in each reference country, in each country relative to the base country. Okay. Now, since it's not obvious which base country you use, they're going to use all of them and just do this thing 15 different ways, one for each country. Okay, so here is the first figure, and this is using the education measure as a measure of skill, right? So this is not the ILS test score measure, right? This is simply the relative supplies in terms of years of education. Now, if this model were right, so by the way, this is the middle versus the low, this is the high versus the middle, this is the high versus the low, and this is all of them. If this figure were correct, all of the dots would be in the upper left or bottom right quadrant, right, if this was the right model. Right, so because basically if they have relative excess supply, net supply is positive, then they should have lower inequality. Net supply is negative, they should have higher inequality, right, relative to the base country. And clearly this does not do very well, right? This is not a resounding empirical success. Now try it again using the ILS test score measure, and this is what you see, right? So here is middle relative to low, middle relative to high, high relative to low, and all countries simultaneously, right? Sorry, all groups simultaneously. And here, the fit is much, much better. So in fact, they use this little binomial test, right? How many of these 630 data points are in these two quadrants, and they get 451 out of 630, right? So the probability of that happening by chance is 0. And so this actually gives you a relatively compelling, simple unified model of differences in wage inequality across countries. So what I want to say, and I'm obviously wrap up the lecture here. So I want to conclude from this, again, as before, the conclusion is modest here. It's not that we understand all international differences or over time differences within countries, differences in wage inequality. We do not. However, you can do reasonably well in understanding both some of the levels and changes over time across countries by using relatively straightforward supply and demand frameworks where skill is measured properly and you specify some very simple relationship between quantities and prices and technology. Now, if we had done this exercise over time using the ILS for multiple countries over multiple years, it might not have done nearly so well, right? This is a cross-sectional estimation. Unfortunately, there is not another ILS sample that we can use. So I don't want to overclaim for this, but what I do want to suggest is it's useful to start with supply and demand as an organizing framework for interpreting wage inequality because it does surprisingly well across industrialized economies. So that's kind of where I want to leave with you here, and then in just a few minutes, I guess, we'll be talking about international trade and its relationship to wage setting. Thanks.